and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Jody Saultz.
Thanks, William. Thanks for joining today. This is part 3 of a 4-part series on stencil cleaning and all about your printer. Today, we're going to talk about IPA versus engineered solvent. So just real quick, solder paste release from the stencil. If you don't understand this, it's just kind of a quick visual of what happens when the board actually is printing. So after the aperture is filled with solder paste, the solder basically sticks to both the stencil walls and the pad itself. After this is done, it goes to a separation. The forces holding the deposit to the pad must overcome the forces holding the deposit to the stencil walls. And depending on the area ratio, a portion of the paste will release to the PCB while some will stay in the aperture. That's the stuff that you need to get taken care of and clean. Some paste may stick to the bottom of the stencil due to stringing or bad gasketing or pump out, or in some cases or most cases, if you're using alcohol, eventually, which I'll show you in later slides, that the alcohol basically has a issue with certain solder paste and it'll basically smear on the bottom side of the stencil. So each element of the printing process must be addressed to make sure that every advantage is taken into consideration. What I mean by that is don't just fix one thing. Look at the paper, look at the speeds. Are you using a wet dry vac or using a wet dry vac or wet vac dry? There's many different combinations that you can use, but not one element will equal success. You have to optimize and do your research to make sure that all of these things that affect the printing will help your printer become more efficient. So we're going to look at solubility, paper selection, and process parameters. So most common practices are dry wipe. These are preferred in some cases, but I never recommend only a dry wipe. They're okay to a point, but if you have tight pitch, small apertures, you're absolutely going to have problems cleaning the stencil. If you're concerned about yields or cycle times, alcohol is not the way to go. So if you're cleaning more or less, less than 5 prints, you should consider a solvent. If you're cleaning, if you're 3 to 5, every 3 to 5 prints, because in some cases, which we'll talk about later, using an engineered solvent can make your machine a lot more efficient. You're going to get a lot more throughput, and you're going to save a lot more money on paper and dispensing of the fluid. So some of the common problems that engineered chemistry can fix, if you look at solder paste defects, this is from poor gasketing or flux buildup on the bottom of the stencil, insufficient pads, increasing prints between wipes from 1 or 2. In most cases, you can double that. I've seen these go from 3 or 4 prints up to 15 prints by using just an engineered chemistry versus IPA. And increasing the number of prints offline for the stencil cleaner. Some customers will run the printer 4 or 5 hours a day, and it gets so gummed up that they have to basically take it out of the machine, which is about an hour of downtime, take it to a stencil cleaner, and basically clean the stencil itself. If you use an engineered chemistry, you can probably just clean that. In most cases, you can clean that stencil at the end of every shift. And more consistent transfer efficiency between prints and wipes. This is with or without nanocoating stencils. Some of the defects, like I said, can be used by using the right solvents. If you look at the top left image, you can see how nice these prints are. And then the middle one, you have a bridge. And then if you look at the bottom left, where it's really ugly, that basically looks like blowout or a bad seal between the board. If you remember, if you watched part 1 and 2, we talked about board support. If some cases, it doesn't matter like I said, what parameter works best. If you don't look and optimize all these parameters, you're going to chase this printer all day long to try to figure out what actually is going on with the printer and why you're getting these bad prints. They lead to poor print definition, like peaks and dog ears. Sometimes, if your stencil is not completely sealing the board, you're going to have a lot of paste that gets contaminated on the bottom of the stencil, which makes it very hard to print the next board. So alcohol, this was pretty much standard back in the day. Until recently, nobody's really focused on that. They just used alcohol. And that was I think it was because basically alcohol is cheap. You can get that alcohol for probably less than $20 a gallon. It's very fast evaporation. And IPA was traditionally used in some of the early flux formations, but really, it's pretty subjective on the low odor side. I think alcohol has a really nasty odor to it versus an engineered chemistry. So it's, I guess, a matter of an opinion. Some people think some of the chemistries out there smell as well, but I think what's really most important is machine compatibility. And this is probably due to flammability. These machines are not built to be explosion proof. So one spark at the right time, while this atomized alcohol is inside that printer, you could have a major fire. So some of the other limitations for IPAs, no cleans, aromatic compositions have changed. In most cases, alcohol will leave streaking on the stencil. It works for a couple of those paste that's out there, but for 90% of them, alcohol does not do a very good job. And we've done plenty of case studies and studies to make sure that an engineered chemistry outperforms alcohol, and it outperforms it by a long ways. It can also damage the printer itself, some of the tooling or rails, and in some cases, it causes a gooey mess. When you start getting this gooey mess on the bottom of your stencil, you might as well take it out and clean the stencil, which is, like I said a little bit ago, pretty much an hour of downtime. So that affects everything. That stops the line, basically, and it costs you hundreds and hundreds of dollars when that printer's not running. And it dries fast. You're going to get higher consumption using alcohol because of the way that it actually wets the paper. So it requires more volume to actually wet. And it's, like I said, it's a poor cleaner. I haven't seen very many print processes out there that using alcohol that allows you to print more than 3 boards without having to clean the stencil. And it can also, IPA, like I said, it dries really quick, so it can dry out the apertures, and it's going to give you poor print release. And the printer manufacturers, they don't really recommend alcohol to be used in their printers. And I'll probably touch on this 2 or 3 times, but you all know it. It's flammable, so choose your fluid wisely when picking a material to put inside the printer. There's always a false perception that IPA is safe, and in fact, it's very unsafe. You know, there's safety regulations in most factories, and alcohol can be harmful if ingested or inhaled. It can cause respiratory issues, loss of concentration. It can affect your nervous system. So alcohol is very unsafe, and like I said, it's very flammable. So make sure you do your homework. Get with your chemistry suppliers. Put a good engineered chemistry in your machine, and where you don't have to worry about the employees out on the floor having any safety issues. So dry wipe and or IPA wipe. This was just basically an image we did with some ultraviolet lighting. If you'll take a look at the top row, this is basically a dry vac. And then the bottom 2 are a wet or a vac wet vac using an IPA engineered solvent. If you look at the center row, you can absolutely see the ultraviolet light. That bluing inside those apertures, that's basically paste that was left over after using IPA versus an engineered solvent on the bottom, which is totally clean. There's no bluing, so no ultraviolet lighting to basically look up or to find that residue that was left over. So by far, engineered solvent outperformed the IPA. So which one of these is yours? I mean, if you look at the IPAs, these are just samples that were taken. This is 100% IPA versus a solvent-based material, and you can see the reaction between both of these. The IPA definitely did not solubilize the paste when it was put into the sample beaker versus the solvent-based, where everything was basically dissolved. If you can imagine what that's doing to the bottom of your stencil, it's this can cause you many problems by not being able to solubilize your paste. So if you can, especially in a new process, steer away from alcohol. If you're using alcohol now, be willing to take the time where you can optimize your printer. If you're using engineered chemistry, trust me, you will save hundreds and hundreds of dollars, if not thousands of dollars a year if you have multiple printers just by changing over to an engineered chemistry, even though that it is more expensive. So steps to success, like I said, pick the right chemistry for that flux or that paste, I should say. Choose the right paper, which we're going to talk about in part 4. And then an important part of the delivery system for the alcohol versus engineered chemistry. If you basically are wetting that paper more than 3/4 of an inch, you're wasting a ton of paper. I see many times when you go in and look at a printer at a customer, and they're basically the nozzle is wetting that paper, and you can see it being wet about 3 inches, 1 to 2 inches on either side of the surface that's actually wiping the bottom of the stencil. You guys are just throwing away dollars. So make sure you optimize that delivery system. It's very important. Um, and you can do this and save a lot of chemistry by using engineered chemistry because, like I said, because of the surface tension and the makeup of alcohol, you're going to have to deliver a ton more alcohol to saturate this paper versus using an engineered chemistry. So pay attention. It's not always cheaper is not always better. A lot of times you're out to save money. If you're out to save money, it's not by using alcohol. Like I said, in most cases, you can go from 3 prints to sometimes 8 or 9 prints up to even 14 or 15 prints before the stencil has to be cleaned from the underside stencil wipe. Take some time, do your work. The proof is in the process. All of this can be tested with the engineered chemistry versus the alcohol. You have SPI after the printer. Basically print until you start seeing failures with an engineered chemistry. You'll get to 3 to 4 on alcohol, but like I said, you should, just by changing over, you should be able to achieve at least 4 to 6. So you should be able to double what you're doing now just by changing to an engineered chemistry. And even though it's more expensive, it'll save you thousands of dollars in the long runs because you're going to save on paper, you're going to save on downtime from cleaning stencils. Your process is going to run a lot smoother, and you're going to have a lot faster throughput. So it's worth looking into. So some of the frequently asked questions on this topic: why does it matter if IPA is flammable? Well, like I said, machines are not built to be explosion proof, and they're man-made. It takes one loose connection at the right time in the right place to hit that atomized fluid that's being delivered to the paper. And the next thing you know, you have a fire. So it absolutely matters. It's very unsafe um, to run IPA in a printer, and it doesn't clean as well. So do your homework. IPA is cheap. Um, So why should I use a more expensive chemistry? Like I said, even though you can probably find IPA for $20 a gallon or less, even if your engineered chemistry is double that price, you're going to save on paper, you're going to save on throughput, you're going to save on downtime due to issues, you're going to save on downtime due to cleaning stencils every 4 hours, if not every 2 hours, by using alcohol. So there's a huge cost savings associated with using an engineered chemistry. All you have to do is take the time, get the right chemistry, and do the testing. And like I said, the proof will be in your process. And number 4, how can I know if my stencil is clean when testing IPA versus an engineered chemistry? Like I said, use SPI. SPI doesn't lie. It tells you the defects. So print until you start seeing these defects on SPI. Probably is going to happen between 2 and 4 prints with alcohol. And in some cases, using an engineered chemistry, you're going to be able to get to upwards of at least doubling that, sometimes 10 to 15 prints, depending on your product and your stencil and your aperture size versus an alcohol. So, and with that, I'll turn it back over to William.
Thanks, Jody. Thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.